All right, just a quick review of factoring. One of the first things you have to do is pay attention to what you have. Notice with that one right there, it says x cubed plus 11x squared plus 30x. They all three have an x in common. So before anything else, factor out what they have in common. They each have one x. So x cubed divided by 1x leaves x squared. And then 11x squared divide x leaves 11x. 30x divide x. And now you've got a quadratic. So factors of 30 that add up to 11, well, it's not going to be 10 and 3. It's not going to be 15 and 2. Yep, 5 and 6. They multiply to be 30. They add up to be 11. So x plus 6, or you could put x plus 5. That part doesn't matter. So if we're just factoring, not solving, then that x looks like it's going to touch. All right. So now I'm going to do that, and I'm going to move these up. Okay, so this quadratic right here has a lead coefficient of 5, so that makes things a little bit more complicated. Let's see if the screen is, darn it, I just undid it. All right, let's see if this screen is going to freeze and I don't mess this up. So 5 is prime, so it's not as complicated as it could be, because you've only got 1 and 5 as factors. I am eating up. Oh my gosh, it's not freezing. All right, let's see if it's... There we go. All right, so it's worth a shot to just start factoring. So we put the 5v and the 1v, because when you multiply, that looks like an r. 5v times v is 5v squared. But now you have to put factors of negative 27. You have to be cognizant of, this is how it works. This 5v times this factor plus this v times this factor will add up to negative 27v. So factors of negative 27, let's see, negative 27 and 1, negative 9, positive 3, and positive 9, negative 3. So let's see, we need it to be negative 6. If we multiply 5v times negative 3, that's negative 15v, and then positive 9 times v is 9v. Yep, those add up. Ooh, I put negative 27v there. It should have been, they need to add up to negative 6v, just like that. So I'm going to put the negative 3 here, and I'm going to put the positive 9 there. These two multiply to be negative 27, and then 5v times negative 3 is negative 15v, 9 times v is 9v, and they add up to the negative 6v. All right, now we're down here to these special circumstances, right? This is a perfect square, and this is a perfect square, and when you have what's called a difference of perfect squares, that's when you have conjugates. Remember that? Conjugates? Conjugates are where they're the exact same thing. Here's an x, here's an x, here's a y, here's a y, but one subtract, one's add, and when you multiply them, the middle terms cancel each other out, leaving a difference of squares. So all you think about is take the square root of that first term. Well, that would be 3n. So you put the 3n in both places. The square root of the second term And now just add your plus and subtract. Doesn't matter the order. You could put subtract here and plus here, or you could put plus here, subtract there. That part doesn't matter. All right, and then finally, erase all, oops. To cover that up. All right. These are both perfect squares right there, but this is what you're going to have to be careful of. Right there, we take the square root of 36n squared, you get 6n. This square root of 64 is 8. But the problem, these all have a 2 in common. So then you would have to factor out that again. These two have a 2 in common and these two have in common. Well, what number does 36 and 64 have in common? 4. So you could factor out, so 36n squared subtract 64. You could factor out a 4. 36n squared divide 4 is 9n squared. 64 divide 4 is 16. Well, look at, now you have the one we have down here. So now you have 4 times the square root of 9n squared is 3n. The square root of 16 is 4. Just like that. All right, that's it for this one.